Students, this is chemical kinetics part 2. You would have seen part 1. I have talked about the rate of reaction and instantaneous rate of reaction. So here I'm going to talk about the factors affecting the rate of reaction. So what's the first factor? The first factor is concentration. Concentration, how does it affect the rate of reaction? See, if more is the concentration of the reactants, then reaction proceeds rapidly. So reactants concentration should be more, then the reaction will proceed rapidly. Next one is about pressure. If pressure increases, then volume decreases, and if volume decreases, then concentration will automatically increase and the rate of reaction also increase. See, because we know that pressure is inversely proportional to 1 by V volume. So pressure increases, volume decreases, and then concentration increases and rate of reaction increases further. Factor is temperature. When there is increase in the rate of reaction, that time there will be a rise in temperature. Next one, nature of reactants. So nature of reactants, it depends upon the specific bonds involved. And here we see that gases is more than liquids, more than solids. So this is where reactants nature occurs. Next one is the surface area of reactants. Surface area of reactants is the reactants are in the powdered form, and when the reactants are in the powdered form, that time the velocity increases as more active centers are provided. And the last is catalyst. It affects the rate immensely. There's a question here. For the reaction given, 4 moles of NH3 plus 5 O2 gives rise to 4 NO plus 6 H2O, and they have given D of NO by dt is 3.6 into 10 power minus 3 mole liter inverse second inverse, and they have asked to calculate the rate of disappearance of NH3 and rate of formation of H2O. So for this equation given, sorry if I have this. So now how do we calculate the disappearance of NH3? Okay, you can easily go on to formation of H2O. So we know that minus of 1 by 4, this is a reactant side, right, of ammonia by dt is equal to 4 of NO by dt. So it get cancelled. Okay. Also you have 1 by 4 d of NO by dt is equal to 1 by 6 H2O by dt from the equation you see here. Okay. Now you calculate that, you get 3 by 2 d is equal to d of H2O by dt. And they gave d of NO by dt as 3.6 in 10 power minus 3 mole liter inverse. So you calculate it, you get d of H2O by dt, you get as 5.4 into 10 power minus 3 mole liter inverse second inverse. That's it. So after you getting this answer, see, the rate of formation of H2O is 5.4 into 10 power minus 3 mole liter inverse, and the rate of disappearance of NH3 is equal to NO by dt. See, the following reaction was studied in a closed vessel, and they have given this equation, and they said that it was found that concentration of NO2 is increased by 4 into 10 power minus 2 moles liter inverse in 5 seconds, and they have asked to calculate the rate of reaction and rate of change of concentration of N2O5. Okay, so the very first is the rate of reaction is asked. So from the product side, plus 1 by 4 dNO2 by dt is equal to, see, d of NO2 by dt, you calculate d of NO2 by dt, because they have told that concentration of NO2 is increased by 4 times. So 4 into 10 power minus 2 mole liter per by in 5 seconds is said. And normally you know the formula is 10 power minus 2 mole liter inverse and second inverse. So second inverse, so you put the 5 down, you get 8 into 10 power minus 3. Therefore here, come back here, 1 by 4 into d NO2 by dt is equal to 1 by 4 into what is d NO2, you get 8 10 power minus 3, so you get 2 into 10 power minus 3. This is the rate of reaction of NO2. Now second one, the rate of change of concentration of N2O5. So 1 by 2 minus 1 by 2 into O5 d by dt is equal to 1 by 4 d of NO2 by dt. So you get it as N2O5 by dt is equal to 1 by 2 dNO2 by dt. So we get it as, you know, d of NO2 by dt is, here we got 8, so we write it as 1 by 2 into 8 into 10 power minus 3. Get 4 into 10 power minus 3 mole liters inverse, whatever. Now I'm going to talk about the third topic called specific reaction rate. Okay, now first point, the law of mass action. We know the rate law equation. Okay, I'll tell you what's the rate law equation. It's written as m1a plus m2b raised to nc1 plus n2d. So c1. This is the rate law equation. M1 and N1, these are the moles, and rate is directly proportional to A power M1 concentration terms and B M2 concentration terms. So it's written as V is equal to K into A M1 and B power M2. So here K is the proportionality constant and V is the velocity constant or velocity coefficient, or you can say a specific reaction rate. So on putting from this equation, from putting A equal to B equal to 1, then we get V is equal to K. Hence specific reaction rate, this is nothing but specific reaction rate, when hence SRR is, so the specific reaction rate, it becomes equal to the rate of reaction when concentration of reactants is taken as 1 unit. It's taken as 1 unit. So what are the units of specific reaction rate? V is equal to K A N1 B M2 into, that is given as concentration by time taken is equal to K into concentration of M1 plus M2. Now that exponents form.